Example 5. Find an equation for the line with the given properties. Express your answer using either the general form or the slope-intercept form of the equation of a line, whichever you prefer. In part A, the slope of the line is negative 2/3, and it contains the point 1, negative 1. All right, so the goal here is to come up with the equation of this line that has certain characteristics. Okay, we know the line has slope negative 2/3, and we also know that the line goes through the point 1, negative 1. Okay, so how do we do this? Well, if you remember when I was introducing you to the 3 different formats for the equation of the line, at the top of page 3, we talked about point slope form, okay? And under the box, it says point slope form is most useful for finding the equation of a line that has certain characteristics. So this would be a situation in which point slope form is going to help us come up with the y equals mx plus b form of the line, okay? So let's go back to our problem here, okay? We are trying to come up with the equation of a line that meets certain characteristics. That means we need to use point slope form. Okay, so I'm going to go ahead and write it down, and then we're going to talk about how we plug into this. So point slope form is y minus y1 is equal to m times x minus x1. Okay, it's a lot to remember. Okay, so the way this works, and I'll write it out to the side, x and y are variables. They are going to stay x and y. Okay, they stay x and y. Okay, do not plug in for those. Okay, what you are going to plug in for, you're going to plug in for m. M is the slope of the line. Okay, and then you see in this equation, you see x1 and y1. x1, y1 is a point that you know is on the line. Okay, so that's actually what we know. We know the slope and we know a point on the line. So we're going to plug in the point and the slope, and then we're going to turn this thing into y equals mx plus b form, and we're going to be done. Okay, so when you're using point slope form, okay, this is point slope form, but this is the template. Okay, I'm going to write it down like what you're going to plug into. Okay, so y is going to stay y, the minus sign is going to come with it. Okay, and then you'll plug in for y1. That's got to equal the slope. You're going to plug in for that. And then put the parentheses, x will stay x, you're going to plug in, or your x is going to stay x, so you need to put that down. The minus comes with it, and then you're going to plug in for x1, close the parentheses. Okay, so this is kind of your template for plugging into it. Okay, so here we go. I'm going to leave it like that so you can use it for future problems. Okay, so I'm going to write it again, and on this line, I'll actually do the plugging in. Okay, so the slope is the easiest thing to plug in for. The m value is going to be negative 2/3 here. Okay, and then we need to plug in for the x1, y1. So when you're given a point on the line, okay, x1 is the x coordinate of the point that you know is on the line. So x1 is 1 here, and then y1 is the y coordinate of the point that you know is on the line. Okay, so -1 is y1 in this situation. Okay, so now we can plug this in. Inside the parentheses, we're doing x minus x1. Okay, so we've got x minus x1 is positive 1. And then on the left side, we've got y minus y1. Okay, so our template says we have y minus, we've got to subtract y1. Well, y1 is -1. Okay, so be careful here. You're subtracting a negative sign. Okay, this is how you would plug into the slope. This is how you plug into point slope form. Okay, so now we're going to try to convert this to slope-intercept form. Okay, so we basically need to put it in y equals mx plus b form. That just means we need to solve for y. Okay, so I'm going to come up here. Okay, and I'm going to simplify what I have. Okay, on the left we have y minus a minus is going to become plus a positive. So we're going to have y plus 1 is equal to -2/3 times x minus 1. Okay, The next thing we're going to do is we're going to distribute the slope through the parentheses. Okay, so we're going to send negative 2/3 here and here. So we're not going to change the left side yet. We're going to have y plus 1 is equal to negative 2/3 times x, and then negative 2/3 times negative 1. Negative times negative will turn positive, and then 2/3 times 1 is 2/3. Okay, we are almost there. Okay, we need y by itself. Okay, so on the left side, you're adding 1 to y. So to undo that, we're going to subtract 1. If you subtract 1 from the left side, you have to subtract 1 from the right side. Okay, so we're going to get y equals, on the right side, you can combine like terms. We can only combine numbers with numbers and x pieces with x pieces. So we only have one x piece, negative 2/3 x, okay, and then we have to figure out 2/3 minus 1. Okay, I'm going to go out to the side and do this. So if we're doing 2/3 minus 1, okay, 2/3 is a fraction, but 1 is not. We can make it 1 by putting 1 over 1. 1 divided by 1 is 1. We haven't changed the problem. To subtract fractions, they need to have the same bottom. Okay, so if you're not sure what the common denominator should be, you need to multiply the denominators together. 3 times 1 is 3. So we're going to convert these fractions to two fractions, each one over 3, and that's what we're going to subtract. All right, 2/3 already has the correct denominator, so we don't need to change the numerator. Okay, but this right fraction has a bottom of 1, and we need the denominator to be 3. Okay, so what we're going to do is multiply the bottom by 3. Okay, if we do it to the bottom, we have to do it to the top. Okay, so 1 times 3 is 3. That will be the bottom, and then 1 times 3 will also be 3, so the numerator will be 3. 3 divided by 3 is 1. That's what we started with. We were subtracting 1. Now we're subtracting 3 divided by 3. That's still subtracting 1. You cannot change the original numbers. Okay, now both fractions have the same bottom, so we can subtract. We can combine them into 1 fraction over 3, subtract across the top. 2 minus 3, that's going to be negative 1/3. Okay, that is going to be your y-intercept here. 2/3 minus 1 is going to be negative 1/3. Okay, that's it. This is the answer. Okay, the answer has been converted to slope-intercept form. Y equals mx plus b. Okay, even though we've written it in this format, notice the slope of the line is negative 2/3. Okay, that's what it's supposed to be. Okay, if you had worked this problem and you ended up with a slope that wasn't negative 2/3, you did something wrong. Okay, now let me talk a little bit about how the answer should be. Okay, if you read the directions, it says to give the answer in slope-intercept form, which we just did, or general form, and it tells you to pick which one you like. I have a feeling in my math lab that they may ask you to put the answer in general form. So I'm going to talk about how you would take the y equals mx plus b and turn it into general form. That way you know in case that comes up. Okay, so I am going to go, let's see, let me go to a new page. Hang on a second. All right, so I'm going to go to a new page and I am going to write down what we left off with. So y equals negative 2/3 x minus 1/3. Okay, that's the y equals mx plus b form, but suppose you were asked to convert this to general form, which is ax plus by is equal to c. Okay, what you're going to do, okay, basically if you examine this general form, the x piece and the y piece are on the left side and then the number is on the right side. Okay, so what I'm going to do here, if I'm going to take my y equals mx plus b form, okay, I'm going to start by moving the x piece over so that the x and y pieces are on the same side. Okay, we are subtracting 2/3 x from the right, so I'm going to undo that by adding 2/3 x to both sides. Whatever you do to one side, you have to do to the other. Okay, so on the left, we are going to end up with 2/3 x plus y is equal to negative 1/3. Okay, now at this point, it's pretty much in general form. I have a number times x plus a number times y is equal to another number. However, it is customary when you write general form to get rid of any fractions. Okay, so what I'm going to do here, notice the two fractions that we do have, 2/3 and -1/3, they have the same denominator. So I'm going to multiply everything in this equation by that denominator. We're going to multiply by 3. Okay, so see what happens when you do that. Okay, we're going to have to distribute it here, here, and here across the entire equation. Okay, so if we did 3 times 2/3 times x, you can put that 3 over 1, and then you have a 3 in the top and it cancels with a 3 in the bottom. And this is going to leave you with 2x. That's the first piece. Okay, and then you're going to have the plus sign, keep the plus sign, and then 3 times y is going to be 3y, okay, equals, and then you have to distribute the 3 to the -1/3. Okay, so if you did that, put the 3 over 1. Okay, you can either cancel here or you can just multiply across the top and across the bottom. Either way, you are going to end up with -1. Okay, so this is the general form of the equation. Okay, so these are the steps you would take if you were asked to give the answer or the equation of the line in general form. Okay, all right, so that is it for example 5a. Okay, the acceptable answers are what I've highlighted in yellow. That's y equals mx plus b. You could have also stated it as the general form, 2x plus 3y is equal to -1.